Okay, 2.6, solving inequalities algebraically and graphically. Okay, there are four rules we need to hopefully remember.
Hold on, wait a minute, hold on.
Transitive property. We talked about this a lot in geometry and you talk about it in algebra. Okay, transitive property says that if A is less than B and B is less than C, then that means that A is less than C. It's using logic to prove something, okay? If one thing is less than, if X is less than 12, if 12 is less than C, then that means X is less than C. Okay, you're using some common knowledge there, some common sense. The addition of inequalities, okay, or the addition property, says that if A is less than B and C is less than D, then that means A plus C is less than B plus D. So you take both that are smaller, add them together, and they're still going to be smaller than the two that were larger added together. Addition of a constant. If A is less than B, and I add C to both sides, A plus C, it's still going to be less than B plus C. If you add the same number to both things, it's still going to be less than, or greater than, or whatever. And then multiplying by a constant, the same thing. As long as the constant is greater than 0, if A is less than B, then that means A times C is going to be less than B times C. If the constant is less than 0, meaning it is a negative number, if A is less than B, then A times C is going to end up being greater than B times C. Because if I have a negative that I'm multiplying with, it's going to work like that. Okay.
Is this all on our book?
It is all in your book on page 211. Okay, there's a chart for it that says properties and inequalities. Now, let me erase this so I have room. We are going to focus mainly today on solving inequalities algebraically, and there are several ways to do so. So, let's start with a simpler one. How would I solve 5x minus 7 is greater than 3x plus 9?
Like terms.
Like terms, everything on one side that's alike, yes? So
Yeah.
I'm going to add 7 and I'm going to subtract 3x. So, yes, so 2x is greater than
16.
divide by 2 and
X
is greater than
8.
8. Okay, x is greater than 8. If I put that on a number line, if I have to graph that on a number line, what does that look like?
You'd have, now parenthesis,
Good, parentheses,
open to the left, like opening this way, like that?
Yeah, like this. Is that what you're saying?
Yes,
Yes, and then I shade
Come to the right.
to the right,
Wait.
okay. What?
because it's greater than,
Because if it's a parenthesis, it's parentheses when it says greater or when it says less than. It's a bracket
If it has the equal.
if it has the equal. Yep. Good, Jenner.
Why don't they do open circle, closed circle?
Because this is like more sophisticated, because when we put it into interval notation, you use brackets and parentheses. So this can be transferred to interval notation like this. That would tell me that 8's not included.
that's my phone, chill.
What?
How can I fix it, Cora?
Okay, how do I solve 1 minus 3 over 2x is greater than or equal to x minus 4?
Get everything on one side.
Yeah, everything on one side. Let's add 3 over 2x to the other side.
It's not my fault people want to talk to me.
And let's add 4 to this side.
My board.
So I get 5, guys, stop talking. It's greater than or equal to 3 over 2 is what? 1/2, 1 1/2.
3 2.
So I get 2.5x, yes? Okay, now what do I do? Divide by 2.5 and you get what?
2 is greater than or equal to x.
5 divided by 2.5 is 2. Okay. And then how do I graph that?
You do
You would do
a bracket
brackets.
at 2,
Okay,
and then you would shade to the left.
to the left. Bracket at 2, shade to the
no
left.
other brackets because it's just an X.
And then if I wrote this in interval notation, okay, 2 is greater than or equal to x, right? It would be like this. Interval notation. Okay, cause 2 is greater than or equal to x, so it's everything less than 2, negative infinity, up to 2. So they might ask you how to write it in interval notation as well, that's fine.
So we have to solve it, then graph it, and then write an interval notation?
Possibly, yes.
Alright.
Okay, so that's what you're gonna be looking at for some of them on your homework. Now, what happens if it gives us a double inequality to solve?
Put it on.
I'm not doing any.
What do you mean put them together?
Like,
Not to
Well,
start.
cause
That's
six
what
x
yours- that's not
minus
even
one is
yours.
the same.
6x minus 1 is the same,
So
so
that's
we're,
in the middle.
good. So Alex is right, we're gonna combine them to look like this, because 6x minus 1 is the same, so it goes in the middle.
Yeah,
Okay? And to solve this, we are going to add 1 to both sides. So you add 1 from here to here and over here. You have to do it on all sides. So negative 3 plus 1 is negative 2, less than or equal to 6x, which is less than 4. Now what do you do from there?
Divide by 6.
You divide everything by 6, all 3 things, okay?
Wait, why is it have to be?
Wait, can you like restart out and
To
make
get
it?
6
Yes.
by itself.
Because this equation has the same thing right here and right here, you put it in the middle. So it becomes like a sandwich, because it repeats, okay? So negative 3 is less than or equal to 6x minus 1, which is less than 3. I have to get this 1 out of the way, so I have to add it here to cancel it, and I have to add it to each side. You have to be equal, you have to be fair, okay? After I do that, I get negative 2 is less than or equal to 6x, which is less than 4. You must divide everything by 6, all 3 portions. What does negative 2 over 6 reduce down to?
Negative 1/3.
So negative 1/3 is less than or equal to x, which is less than,
2 2/3.
how about 2, yeah, 2/3. Okay, which is less than 2/3. Now, how do I graph that?
You put, bracket, bracket at 1/3,
At negative 1/3?
at negative 1/3,
Okay, so let's like say that's here,
and then you shade to the right,
okay?
and then you put a parenthesis at 2/3,
Okay, which is like here.
and then you shade in the middle.
So these are your solutions, yes? So when I write this in interval notation, I write it as bracket 1/3, parentheses 2/3. Okay, I write it like that. So the only numbers that will work is anything between negative 1/3 and 2/3 to make that statement true. Okay, so you gotta combine them and then solve it that way. Now, when you are dealing with absolute value, remember you always have to set up 2 equations. Even if they don't show it to you, you have to set up 2 because absolute value has a negative and a positive that can go into it, yes?
Yeah.
Okay, so you're gonna set up 2 equations, and when I go to set up these 2 equations, one has to say less than, one has to say greater than, okay? We're going to then take these 2 equations, and once again, this is the same thing, right? The x minus 5, okay? So we're going to sandwich that in the middle. We're gonna say,
How is it gonna be that long for one?
that's a good question, we're gonna talk about that. So, if I have this as a 2 and this as a 2, right? What would be the negative of that? Negative 2. So I'm gonna say negative 2, okay, because we have to have a negative and a positive answer. And I'm going to say negative 2 is less than x minus 5, which is less than 2. That's how I'm gonna change those into what I'm doing. How do you,
The
what?
one on the left is less than 2, but the one on the right is greater.
Okay, let's talk about that.
so what do we do with the x minus 5? Did we just take off the x minus 5 because they're the same? We put them in the
stop.
middle because it's the same?
Let me rephrase this, because I don't think I phrased it right. We have to make 2 equations for this, we have to make 2 equations for this, they're separate things. Okay, so this one here goes with, that goes with this one here goes with this equation, okay? Because this says less than.
So does it lose the absolute value bracket?
It does lose the absolute value. When I wanna make an equation for this one,
Then the
okay,
sign needs to be
I'm gonna
opposite.
say 2 is greater than x minus 5, which is greater than,
Okay,
or negative 2 and 2, yeah.
okay.
Negative 2 is greater than x minus 5, and which is greater than 2.
So even if the, absolute value, the things that are inside the absolute value were different, you would still do the same format? You set up the same way?
Repeat.
Like if you
So
have
like
two
if I have x plus 5 and then x minus 6, would I still set
Oh,
up the exact same
Okay,
way?
so, no, okay, yes. Let's do this. Focus on that for now. Let's focus on that for now, then we'll come back to the other one.
Alright, my fault.
Okay, let's do this one. So if we focus on this one, we set up our equation to say negative 2 is less than x minus 5, which is less than 2. Add 5 to everything. 3 and 7? 3 is less than x is less than 7. Great, now how do I represent that?
You put, parentheses,
The parentheses
at three,
around
parentheses,
3 and
7, shade blue.
Good, so we're gonna say 3, we're gonna say 7, we're gonna put parentheses, shade. I write it in interval notation as 3, 7. Okay, now let's go back to this. Let's say that you have, was it x minus 5 first again? Is greater than 2. Okay, now with this one, we have to set up two different equations, okay, to solve it. Because negative 2, okay, we have to use negative 2 and we have to use positive 2, correct? Okay, so we're gonna say, it says x minus 5 is greater than 2, correct?
Yeah.
Okay, so x minus 5 is greater than 2, we put that in just like it is, x minus 5 is greater than 2. But when I switch it to negative 2 this time, I have to also switch my sign. So I'm gonna have this, or, I hope you guys can like follow along with all these little giggles back there.
Cora, will you shut up sometimes?
Jeez.
So you have x minus 5 is greater than 2, you just drop those absolute value signs and solve that way. Or if you want to set this one up too, you have to make a less than sign for negative 2, okay?
So do you do the two separate ones when the inverse of that doesn't fit the equation?
Correct,
Because you can't put negative 2.
Correct.
Because 2's least value.
right, exactly. Good, Winston. Very, very right. Okay, that's very smart. Okay, so then from here I just solve, and I get x is greater than 7, right? And from here I solve
Greater, or less than.
x is less than 3. So then when I number line that one, right?
But when I put parentheses at 3 and 7,
Yeah,
then you
well,
shade the outside.
right. So one's at 3, right, and one's at 7, and they're going away from each other, correct?
Yeah.
Okay? And then if I make that into interval notation,
You're gonna make them separate.
you have two separate ones. Okay, so interval notation for this one here is negative infinity, right? Negative, draw negative, stupid. Okay, negative infinity to 3. Union, that's what the U stands for, means like you have to have both things, union. 7 to positive infinity. So you have to write interval notation for that, two different things, and you have to unify them with that union mark, okay?
Union.
Yeah, because it's basically saying you can't have one without the other. Both of these things make it true. They have to be unified.
Wait, so you have to have both equations?
You do have to have both equations.
Because the inverse doesn't fit in the equation.
Right, because if I did the inverse, he's right. If I do the inverse, it doesn't make that statement true, it doesn't fit into that equation. So you have to flip the sign and change it so that you can solve
So
it.
that only happens when there's like an absolute.
Yes, it only happens if there's absolute
Like she just wrote it.
value going on. Okay? It only
So that
happens
happened too with the top one or no?
What happened with what?
The top one up there?
No, the top one is fine, because when I plug negative 2 into here, I get negative 2 minus 5, which is negative 7, right? Wait, no, this one works because it's less than,
Because the inverse.
because negative 2 is less than this, the inverse is correct. Down here, the inverse would not be correct, so you have to create two separate equations.
What would you do when, like, if that one was like, negative 3 is less than or equal to 6x minus 1, and then it was like, and 4x plus 2 is less than 3? Like,
When it's an and, they will have something in common, and that's what always goes in the middle, okay? So if it's an and, you're going to have common. It won't do that to you. That's where this property comes in. That's what they're talking about here. The transitive property comes in, because I can do that instead of pull it out, okay? The last thing we're gonna talk about today, and then tomorrow we'll hit more on this, is polynomial into behavior. So if I have x squared minus 3, okay, and I wanna figure out what would this graph kind of look like, okay, without doing it in my graphing calculator, if I wanna say, what do I think it's gonna look like? There are a couple of steps to figure that. First, you have to factor this. This is technically, like if it would say x squared minus 4, what would that be considered?
Perfect square.
So it would be a difference of
So it's-
squares, and you would have a positive and a negative, yes? Okay, it's kind of the same concept here, but I know it's not a perfect square. But if I set this equal to 0 and solved, you would get x squared equals 3, right? And you would take the square root and you would get x equals plus or minus radical 3, yes? Okay, that's how I get these when I factor. So I got x minus 3 and x plus, or x minus radical 3 and x plus radical 3, because when I FOIL those, I'm gonna get that as my answer. So when you factor this, if it's not factorable, you kinda have to set it equal to 0, solve, and then put those into a positive and a negative, okay? From factoring that, we need to figure out our intervals, okay? These tell me what my test intervals are. So I set up one off of here, and this one's negative, so I have negative infinity to negative radical 3, okay? I set up one that's in between, negative radical 3 to radical 3. And then I set up one that is the in part of my behavior, radical 3 to positive infinity. Okay, I set up 3 test intervals. Okay? And then they just chose values from there to plug in. Okay? They chose, let's choose negative 3. Does that fit into this test interval? So I can pick any number that is less than radical negative 3. Okay? And they chose something they knew would come out easy. Because negative 3 squared is 9, 9 minus 3.
So is there kind of like a sign,
Is there kind of like a sign? What are you?
like if they're going off the x minus radical 3, like it's like x can go up to negative?
Correct, correct. Because there's not a bracket, it's not going to use that number, so you have to use something that fits within this test interval.
So there's like an invisible sign
Yes,
between the x and negative radical 3.
correct. So then I have x and negative 3. If you do negative 3 squared, you get 9. 9 minus 3 is 6. That is a positive output, yes? Okay, so that's how I know what my sign is. It's positive. Then I'm choosing something between these. The easiest number to choose between these is 0. So 0 squared minus 3 gives me negative 3. That is a negative output. Okay? Then I have to choose something in my last test interval, which is radical 3 to positive infinity. They picked 5 because 5 is an easy number. 5 squared is 25, minus 3 is 22. So I put a plus sign there because it's a positive output. So my graph goes positive, negative, positive. Okay? Which means my graph is probably going to be something, and it's a square, so what shape is it? If it's a square, what type of shape do I get when I have a square function? A parabola. So it's a parabola, so it's gonna start positive, and it's gonna fall to negative and go positive. So it's going to look like that, it's gonna face that way, okay? The only thing I need to figure out are like, what are my intercepts, right? So if I figure out where my vertex is, I can figure it out by plugging in a 0 here. When you plug a 0 in, what do you get? Negative 3. So I know my turning point is going to be at negative 3. I know that my intercepts are radical negative 3 and positive radical 3. So if I put that in my calculator, because I don't know what that is off the top of my head, radical 3 is 1.7 and negative 1.7, okay? So I have my graph now.
If you want us to put 1.7, just
Something like
leave it
that.
radical 3.
You can leave it radical 3. And I know that it goes positive, negative, positive. Is that how it showed?
So what is
Your rest of the choices. To do the problem, you're going to have to find your test intervals by factoring it first. Create your 3 test intervals, and then plug a number in from each of them to tell if it goes what the signs are. That's what you're gonna have to do.
What if it was like negative, negative,
That's
positive?
what nobody likes. That's what you miss.
What the graph-
That's what you miss.
Then it would be going down, down, and then swoop up.
So it can do that though?
Mhm.
Go negative, negative,
It
positive.
could. Boo. Okay?
Oh, that's good.
You can just
So then
put it
let's
over
solve
the
this
trash.
last one and then we can start some homework.
This is only one part?
Yeah, I told you, this is a long section.
Wait, Miss Peter,
Goodness.
Yes,
like 2 days
how did you get x equals 5?
you pick a number that's within here, it doesn't matter. So I can pick anything that is larger than radical 3. I could have picked 22 to plug in there.
You have picked 1,000.
You could have. So you can pick any
Yeah,
number that
Jared.
fits in that test interval, okay? I just picked 5 because 5 has a perfect square, that's easy, that's why. Okay, I could have picked 3, I could have picked 4, I could have picked anything, okay, and it would still come out as positive. How do I solve this? 2x squared plus 5x is greater than 12. What do you need to do first? What do you think?
You need to
Say.
divide, wait. You divide by 2 the leading coefficient.
You can't divide by 2 because 5 is not divisible by 2 perfectly. Do what, Mads? Yeah, put it all on the same side. Let's subtract 12 over to the other side so that we can factor.
Oh, so they go
2x squared plus 5x minus 12 is greater than 0. What multiplies to give me negative 12 adds to give me 5 with a leading coefficient of 2?
I don't know.
Full oh, you can just like do it to multiply with a 2, right? 4 and 3, maybe.
Well, what's 4 times 2? That's 8, right?
So it'd be 6 times.
Oh, no, you're right. It's 4 and 3.
Oh,
Yeah, Jenner.
It's going to be positive 4, and it's going to be negative 3, because 4 times 2 is 8, minus 3 is 5.
Okay, then, Jenny.
Good, Jenner. Now, what from there do you think I need to do?
Gosh.
What are you talking about, Cameron?
I gotta find test intervals, which means what am I doing with each of those? Parentheses.
Right. Are those your test?
They are my test intervals, but this would technically be 2x minus 3 equals 0, right? So you would get what as your,
Oh, x equals negative 3.
yes, so 2x equals 3, so x equals 3 over 2, it's positive.
Yeah.
And then this would be, yeah, x equals negative 4. So my test intervals are 3, 2, and 4, right? And they, oh, negative 4, sorry. Good, thank you.
Wait, you said 3, 2?
Oh, 3 seconds.
Okay.
3 seconds and 4. So I have this.
What did you just say?
What shape is this again? A parabola. A parabola, okay? So I have negative infinity, right, to negative 4 as a test interval. I have negative 4 to 3 seconds as a test interval, and I have 3 seconds to positive infinity as a test interval, yes? Okay?
How do you know which one to put with?
Because I go from least to greatest on this. So negative 4 is the like negative side of it, so it's negative infinity to negative 4. And then I have to start at negative 4, pick up there, and go to the next thing that x equals.
Right with it.
Yes, yes. And then I go from what x equals to positive infinity, okay? Now from there, I have to figure some stuff out, okay? So after testing the intervals, what do you think is gonna happen? What numbers do you wanna pick?
Negative 5, 0, 5.
You wanna pick negative 5? Okay, so negative 5 squared is 25, right? 25 times 2 is 50. And then minus 25 minus 12, correct? So you would get 13 out. So that would be positive. Okay, so positive. What did you say here?
0.
0. So 0 would give me negative 12, so it would be,
Negative
and then here we said
5.
5. So 5 squared is 25 and 50 plus 25 minus 12 gives me 63.
Oh, you just put it back into the equation.
So parabola again, okay? What is my 0 of this? If I plug 0 in, you would get,
What's the turning point would be negative 4 or
yeah. So my test, yeah, so my intervals would be the same as what happened over here. It would be negative infinity to negative 4, and then it would be unified by 3 seconds to positive infinity, yes? Okay, so So that's my test, or those are my intervals of where it turns, so my intercepts are -4 in 3 seconds. 3 seconds is 1.5, right?
Oh, so we'll do.
But remember your vertex is in between those. If you remember from algebra 2, you would do p plus q divided by 2. My p is -4, my q is 1.5. So -4 plus 1.5 gives me -2.5 divided by 2, and you get -1.25 as your x. So -1.25, and then I plug that into my equation to get my y out. So -1.25 squared times 2 minus 5 times -1.25 minus 12 gives you -2.6. So it's gonna be something like this. And then it's gonna go like that.
Ms. Peters,
What?
So you-
Does it
yes.
make you feel
so
uncomfortable?
where are you plugging in?
I'm plugging back into this.
What?
Right here.
Oh,
To this one where it's
so
greater
you,
than here.
so you just plug into -4?
No, the -4 is an intercept, I already know that. Because when I factor it, that tells me my intercepts.
Wait, so what do you plug into?
I plugged in, if I take -4, if I take this intercept and add them together and divide it by 2, you get -1.5. That's what I'm plugging in. That's my x of my
I mean,
vertex.
like, to get the pluses and minuses sign.
Oh, once again, you plug in any number that's in this. We plugged in -5. You plug any number that's in here, we plugged in 0. You plug in any number here, we plugged in 5, and that's how you get pluses or minuses. Any number that's in that parameter,
First, instead of first.
okay? Any number.
And so, to get to the 5, you need to.
That's what we're
have
working on
to
today.
have to get to 5.
So I hear like
But you need
5
4 and
problems.
3 to